While the James Webb Telescope utilizes its infrared vision to investigate the most distant and oldest secrets of the universe, we shouldn't forget one thing. Probably the greatest big secrets are right next door. Despite the fact that you might imagine that the moon has been completely decoded by now, our reliable companion still holds a number of unresolved mysteries for us. In fact, we couldn't say with full confidence how our satellite was formed in the first place. However, gravity field measurements have uncovered that a massive structure lies beneath the surface on the mysterious far side of the moon, which occasionally sparks the most stunning hypotheses and theories. But are we really dealing with the secret base of an ancient lunar civilization here? Or can the presence of the lunar giant perhaps be explained differently? Where the natural view is limited, nothing disrupts the flow of the most daring fantasies and legends. The reason for this is simple. No matter how much we crane our necks, it's just impossible for us to get a glimpse of the strange far side of the moon from Earth. The explanation for this is straightforward. Our natural satellite has a bound rotation, so it always presents the same side to Earth. But why is that so? Well, in this regard, specialists point out that our satellite has only gradually acquired this characteristic. Not long after its formation, the moon actually turned much faster. Over time, however, Earth's gravitational pull gradually slowed it down to the point that its rotational speed eventually matched its orbital speed. In this coupled rotation, for millions of years, humankind could only speculate about what was hidden on the far side of the moon. But as we all know today, we have a variety of means available to explore the so-called dark side of the moon. Actually, we knew some time before the Chang'e 4 mission, which in January 2019 became the very first spacecraft to land on the far side of the moon, that it's not quite as dark as it's often mistakenly claimed. In fact, the dark side of the moon goes through the very same phases as the near side, just in the reverse order. And if we look closely, we might even see the far side of the moon, at least the more obscure side, the region facing away from Earth. In fact, it has a higher reflectivity than the opposite side. And each time the satellite presents itself overhead as a new weak bow, its far side is brighter than the front side at full moon. The term dark side, therefore, refers less to the fact that the far side of the moon gets less sunlight than the near side, but rather to the fact that for our ancestors, it symbolized the great unknown for quite some time. But despite all the phases of the moon being equivalent, it is undisputed that the two parts of the moon couldn't be more different in various respects. Unexpectedly, we have only known this since 1959, when the Soviet probe Lunar 3 sent pictures of the previously invisible region to Earth for the first time. And then, as now, a quick look is enough to see that the dark Maria, the swamps covered by hardened magma, make up a small part of the surface here. By comparison, the near side of the moon contains nearly a third of its surface area, yet far fewer mountains and craters grab our attention on the far side. Now, specialists believe they have finally solved the mystery of the different nature of the two sides of the moon, but more on that later. First, we should deal with another no less interesting report. Gravity field measurements have provided a completely unexpected insight. The far side of the moon is home to a gigantic structure that presents space experts with a huge puzzle. The mysterious giant structure is comparable to Hawaii. It's always worth a visit. Anyone who visits the main island, which is over 10,400 square kilometers in size and gives the state its name, can look forward not only to various black sand beaches, but also to the imposing volcanoes Mauna Loa and Mauna Kea. But what does an idyllic getaway in the Pacific have to do with a grand discovery on the far side of the moon? Well, it's quite simple. Peter B. James of Baylor University in Texas can be quoted as follows. Imagine a pile of metal multiple times bigger than the main island of Hawaii and bury it underground. That's roughly the surprising mass we found. But how did it come about, and what does it all mean? To understand this, we first need to take a closer look at the location of the said massive mass. After all, we're not talking about just any spot on the surface of the moon here, but the South Pole Basin, which is nothing less than the largest preserved impact crater in the entire solar system. It stretches over more than 2,000 kilometers. But how the violent impact, which is estimated to have occurred 4.3 billion years ago, took place in detail and what consequences it had for the young moon is still largely unclear. To shed some light on the lunar mystery and also find out what the South Pole Aitken Basin subsurface is made of, James' team looked at data from the Gravity Recovery and Interior Laboratory GRAIL mission. As part of this, 2 space probes launched in September 2011 aimed to measure the moon's gravitational field and irregularities, gaining insights into the interior structure of our satellite. The researchers combined this gravitational data with that of the Lunar Reconnaissance Orbiter, which is dedicated to mapping the entire lunar surface in high resolution and measuring cosmic radiation exposure. As mentioned, the experts' analysis ultimately uncovered the presence of a massive mass anomaly hidden many kilometers beneath the South Pole Aitken Basin. And we're talking about a huge mass anomaly here. After all, it reaches a depth of 200 kilometers and weighs in at 2.18 quadrillion tons. By comparison, this is roughly equivalent to half the mass of the Earth's atmosphere. However, the Webb wouldn't be the Webb if it only searched for natural explanations in this regard. Against the carefully designed, somewhat more alternative background that we've never actually been to the moon, some theories suggest it could even be an artificially made space station disguised as a celestial body. The idea of a secret underground base for lunar inhabitants didn't seem far-fetched to some, and it's an astonishing thought. Even the more cautious scientists still can't say with full confidence what the true explanations for the mass anomaly are. Of course, their theories are not based on the work of an unknown lunar civilization, but rather on the metallic core of the asteroid that created the South Pole Aitken Basin billions of years ago. This core may still be embedded in the moon's mantle. After all, virtual simulations have shown that such an iron-nickel core could have penetrated deep into the upper mantle during an impact without necessarily striking the moon's core. Furthermore, the enormous weight of the asteroid's core could have pulled the bottom of the crater down, making it sink by an additional kilometer. Another alternative explanation for the mass anomaly involves a massive chunk of dense oxides that once accumulated at the moon's south pole when the original magma sea cooled and solidified. However, only the future will tell which of these theories is correct. Theories eventually match reality, and it's conceivable that the mystery of the moon's subsurface structure will be settled through a manned lunar mission. Why does the moon have 2 faces? The catastrophic impact at the moon's south pole couldn't have just left behind a confusing mass anomaly. It could also be responsible for the radical differences between the 2 halves of the moon. In addition to the aforementioned mass imbalance, researchers have now discovered that the crust on the far side of the moon is considerably thicker than that on the near side. At the same time, the surface of the near side is enriched with unusually high concentrations of radioactive thorium, potassium, phosphorus, and rare earth elements. How this so-called jerk region was formed and what triggered the volcanism on the lunar surface, however, remains equally muddled and disputed. Some scientists suspect that the reasons for the differences in the crust lie in the tidal forces exerted by Earth. Others, however, believe it's more plausible that these differences are the result of a massive impact. Matt Jones from Brown University in Rhode Island is one of those who supports this view. That's why he and his colleagues investigated how the immense heat from the impact at the South Pole Aitken Basin might have affected the entire lunar body. As it turns out, the massive impact site is located precisely at the point opposite the near side of the moon. Recreating the effects of this enormous impact based on geophysical models of the early lunar interior later showed that the impact could indeed have caused a thermal anomaly in the moon's mantle, which fundamentally influenced the development of the moon's interior for billions of years. The fire-up event, with a 100 km-sized asteroid, released an extreme heat surge that spread through the moon's interior to the far side, eventually affecting the region known today for its many Maria and the cold trap areas. In the process, titanium-rich magma gatherings were also swept toward the surface, just as a surfer follows a wave. According to the simulation, the heat and subsequent mantle convection would have been sufficient to explain the remarkable development of the far side and the basaltic rock of the Maria. But that's not all. The impact at the moon's south pole may have even paved the way for volcanism and the formation of the Maria in the first place. In fact, the event may have focused heat-producing elements on the near side of the moon, and the combination of radioactive heating and increased mantle convection could have literally energized the upper mantle of the near side over millions of years. The hot magma could then have spilled out onto the surface in the form of large eruptions. According to the scientists, the first eruptions occurred around 200 million years after the asteroid impact, while the most intense phase of lunar volcanism began another 300 to 500 million years later. In other words, the evidence is mounting that the South Pole-Aitken Basin impact and the characteristics of the moon's near side are directly related, and that one of the greatest mysteries in lunar research may have finally been solved. And now, it's your turn to crack the following mystery. What is found directly beneath our video? Just waiting to be tapped by you? That's right. Feel free to click like and subscribe so you never miss a new video from us again. We'll see you soon.